Okay guys, the last section that we have is 8.2, and that's solving differentials using matrices. Alright, so a couple things here, right? So when you're dealing with dx over dt and dy over dt, you have these linear functions, and a couple things here like x prime will be obviously x prime y prime of t, and x is going to just be x and y, x and y of t, you could say. All right, so when you rewrite this, it's going to look like x prime equals, you take all the coefficients 1, 2, 4, 3, and then times x. So again, like you could see, the coefficients match, right? And the next thing that you have is it's always going to be written in the form of x prime equals ax. Okay, so in this situation, A is going to be this matrix. So a couple things we want to do. The first thing we want to do is find lambda. Okay, this is an eigenvalue, they call it, eigenvalue. We're looking for those first. Okay, so in order to do that, right, what we want to do is take the determinant of a minus lambda times the identity and then set that to 0. So a couple things you need to know, right, is what is the identity? Well, the identity is 1, 0, 0, 1. Okay. So whenever you have something like lambda times the identity, that's just going to be lambda times this matrix. And since lambda is just a scalar, it'll be lambda 0, 0, lambda. Okay, so you could use that as well. So let's just first do, like, what is the value of a minus lambda, right? What is that value? Well, in this case, we know what a is, 1, 2, 4, 3, minus, well, lambda I is just going to be lambda 0, 0, lambda. And then what you're doing here is just subtracting. So you would have 1 minus lambda, and then 2, right, because it's 2 minus 0. 4 minus 0 is just 4, and then you have 3 minus lambda. So that's just a minus lambda. Now the determinant of a minus lambda I, what you're doing again is just, you're taking these two and then subtracting, multiplying those two. So what it looks like is you'll have 1 minus lambda times 3 minus lambda, and then minus 2 times 4. So that gives me 3 minus 4 lambda plus lambda squared minus 8, which is going to be lambda squared minus 4 lambda minus 5. Okay, what we want to do is set that to 0. So we're going to set that equal to 0, and I wind up with lambda minus 5 and lambda minus 1, plus 1, sorry. So I get lambda 1 is going to be 5, and lambda sub 2 is going to be negative 1. So this is important. This is the first thing that you want to find, is our eigenvalues. Okay? Once you find those values, all right, once you find those values, so what we're going to do next is we're going to do a similar thing. We're going to say, okay, I want to find out, well, okay, a minus that lambda I of x, and I'm going to set that to 0. So remember that in this situation, right, you're going to have x is going to be that x comma, like xy, okay? So here I'm going to have 1, 2, 4, 3, because that's my A, minus, well, we know lambda I was just lambda 0, 0, lambda. And then we're multiplying that by x. Remember, that's just xy. And we're setting that to 0. So in this situation, just to show you how I'm going to get these, is I'm going to do 1. My bad. We need to pick a first, lambda. So let's start with lambda of 1 equaling 5. And I forgot to put that in there, right? So it's actually going to be 1, 2, 4, 3, minus, instead of lambdas, we're going to have 5. All right, my bad. And then times x, and we're going to set that to 0. So, sorry about that. Okay. Well, in this situation, when you're doing this, you're going to do 1 minus 5, which gives us 4. And then because it's in that first column, right, that has an x. Just remember, maybe I should just do this for you guys and put xy, right? So that first column goes with x, and then the second, right, 2 minus 0 y, right? So 2 minus 0 is 2, so you have plus a 2y equals 0. And then we do the same thing. Okay, so if it's 4 minus 0, which is 4, times x, which gives me 4x, and then I do the same thing here. Oh, sorry, negative 4 there. And I do the same thing here, and let's say we have 3 minus 5, and times y, so that's negative 2y equals 0. Now for both of these are equivalent. You can see that it's just negative. So either one that we solve for, we're going to get y equals 2x. So now just write it this way. If x is equal to, say, p, right, then y has to be 2p. Okay? Then just look at your coefficients for p and 2p, right, and then we get a k sub 1 to be 1, 2. All right, bear with me here. Now if lambda, so lambda sub 2 is negative 1, we're doing the same thing. So it's a minus lambda I, right, and we're setting that to 0. So I still have the same matrix, 1, 2, 4, 3. Lambda this time is negative 1, which is going to make that a positive 1, and then you have 1, 0, 0, 1 equal to 0, right? Oh. Times x, and that's equal to 0. So again, same idea. You're going to have 1 plus 1, so that's 2x plus 2y equals 0, and then you'll have 4x plus 4y equals 0, and you should see these are scalars of each other, so we wind up getting, like, let's say x is equal to p, then we know y is also going to be equal to, oh, my bad. So let's just solve, right? So say I solve for y, right? So y is equal to negative x, so if x is equal to p, y is equal to negative p. So again, in this situation, we'll have k sub 2 equal to 1, negative 1. All right. So now that we know what k sub 1 is, right, we got that before, 1, 2. K sub 2 is equal to 1, negative 1. All right, once you do all that work, right, this is very tedious in this sense, our solutions will look like this. X equals C1 X1 plus C2 X2. Just like any other normal thing, okay? X1 is going to equal K sub 1 e to that lambda sub 1 t. So if we go back, remember lambda sub 1 was 5 and lambda sub 2 was negative 1. okay? So really those are our goals that we want to get, because once we get there, then we could use this. In case of 2, like x sub 2 is going to be e lambda of 2 times t. So in the first one, right, x sub 1 will just equal 1, 2, e to the 5t, and x sub 2 is going to be 1, negative 1, e to the negative t. All right, so now our solution will equal, or will be, sorry, C1, 1, 2, e to the 5t, plus C2, 1, negative 1, e to the negative t. All right, and that's what you have there. Now the way that would look, you could leave it like that, I would leave it like that, but if the way that would look would be like C1 e to the 5t, plus C2 e to the negative t, and 2C1 e to the 5t plus minus C2 e to the negative t. But again, you could just leave it like that, how you see it. All right? And that's A2, and that's it. I think that should be enough.